Okay. Okay. So this is the additional lecture for some parts in chapter 1 and 2. So for the chapter 1, let me start with the logarithmic functions. Okay. So I hope from here you can get a better understanding and maybe better in terms of practical use for a function. So let's start with the chapter 1. I'm skipping the logarithm function, but I will add now to review. So hopefully you can get the idea of logarithm functions. Okay. And I think most of you are familiar with logarithm. So let me write. First is logarithm or logarithmic function. Okay. All right. Let's start with some words here. If p is greater than 0 and b is not equal 1, exponential function is either increasing or decreasing. And because of that, this is 1-to-1 function by horizontal test. Horizontal line test. Okay. So it is exactly crossing 1 point. Okay. If so this is exponential. Okay. So if therefore so if this exponent has an inverse, which is called the logarithmic function, okay, with base b, and we can write log b. So this is called the base. Okay, the b called the base. Okay. So from the formulation of the inverse that you have learned, so if this is inverse is equal y, then f of y is equal x, right? So we have log base b of x it's equal y. We can write this in terms of base with the power of y equal x. Okay, so the log here is the inverse of the exponent. Okay, so this is exponent, this is log, right? Okay, now we can also write this and exchange x with b with the power of x, then it will be x. Okay, remember the inverse concept. Okay, so we can have also this is for every x element of the real number, and this is for every x greater than 0. Okay, so Um, if you want to draw, we can draw this. Okay, let's say this is the y equal x. And remember that y equal x is needed because if you want to reflect the functions to find the inverse, okay, you need the y equal x. Yeah, more or less, this is the functions. So this is log. This is the exponent. Okay. So as x approaching 0, it's going down. And another term that is usually we will going to use in calculus frequently is e, right? So Euler number. I will tell you in the class why we need e and what is actually e. But actually e is an irrational number, which is it's around 2.78 something, right? So it's around 2 and 3, but it has a certain property. So it has unique property in which if you have um, log e, we can replace this with ln. Okay, so we can write ln x, right? So if we have the function ln x, this means log e x. Okay, the base is e. Okay, and the unique property from this e is when you have ln e, this is equal 1. And if you have ln e to the x, this is equal x. Okay, of course with the inverse concept. And if you have this is also x. It's actually same thing as e log ex, right? Okay. Okay, I think that is the um, important additional things. Okay, another thing from this from log, aside from log, is about the inverse of trigonometric functions. Okay. Okay, let me go and tell you. Okay, let's. Okay, hopefully you can get like level up from this additional lecture. So inverse trigonometric. Okay, remember that the trigonometric functions, the original one, not the inverse. The trigonometric function is not 1 to 1. Why is that, and why we can conclude this? Because we can have, okay, uh, for example, in sine, when we test with the horizontal line test, It's not one to one, right? It's crossing more than one point. So it's not one to one. So how do we make this trigonometric one to one? We can just look at maybe from zero to here, from zero to a point here, maybe pi over 2. And we can see from here, just this domain here, that the function will be one to one. Okay. So we can restrict the domain so that the function become one to one. All right. Or to be precise, for sines, I think it's also okay if you just restrict from here. Sorry. I think, yeah. I think it's still okay. From minus pi over 2 until pi over 2 is still one-to-one functions. Okay, let's restrict the sine functions to be at domain. So let's let domain from, okay. So we will have okay. Let's say this is negative pi over 2 and this is pi over 2. Okay, let's say that that's our functions now. So we have y equals sine x at its domain, negative pi over 2 until pi over 2. Okay. All right. All right. Since the definition of the inverse, since this is the definition, so we will have sine inverse x equal y, and sine y is equal x. And y will be from negative pi over 2 until pi over 2. So remember that the domain become range becomes domain, right? Okay, so if, okay, the x value. So remember that the sine have maximum and minimum value of 1 and negative 1, right? So we can have, so negative 1 less equal x less equal 1. Sine inverse x is between, okay, so we have this. And sine inverse of sine x is x, and sine inverse x, so x, that is the property of the inverse. This is for this x, and this is for, okay, so you need to look at domain and range. It's exchangeable. Okay. All right, that's for sine. For the cosine, we have uh, it's actually similar, but because in cosine we have uh, movement for the angle around pi over 2, right? So we will have maybe from 0. Okay, maybe that will be our domain here until pi. So from 0 to pi for this cosine. So this is a cosine. Okay, let's limit the, or let's restrict the domain from 0 to pi. Okay, so it's from 0 to pi for the functions of cos x. So this will be 1 to 1, right? 1 to 1. And we can write some terms here. That is the inverse and the range will be from 0 to pi. And we can cancel these equations with the inverse property. Okay, so it's actually pretty similar, but the difference is the domain. Okay. Now we have the tangent. The tangent is oh, let me draw the sign. I forgot to draw the what is the inverse. Let me draw here. Sorry. So if you look at and imagine there will be a y equal x here. So you can reflect and then you can have, or maybe let me draw the y equal x and then draw the reflection from there and there. Okay. I think more or less this is the inverse. So this is pi over 2. This will be negative pi over 2. This will be negative 1. And this will be 1. That will be, this is sine inverse x. Okay. Or we can say, if you like, it's arc sine x. We can also say with that uh, terms. Okay. But for me, I prefer the sine inverse. Okay. For the cos or inverse, cosine inverse, okay, let's imagine from here, we can have the reflections there. So, so some part will be reflected to the left and some part will reflected to the right. So let's say we have pi over 2, or maybe not there, maybe here. Pi over 2 and the pi over here. And this is 1, negative 1. Okay. All right. Now move on to the tangent. We have the tangent. Okay, if you remember the behavior of the functions for tangent function, we have the infinity, right? From here to here. And from 0, and then let me make the asymptote, or maybe the asymptote with red color. Asymptote 1, asymptote 2. Actually, there is a lot of asymptotes, but we are restricting only minus pi over 2 and pi over 2. Okay. So from here, going up, we are around there, and then going there. Okay. Yeah, more or less tangent x. From minus pi over 2 until pi over 2. Not, sorry, not equal, because it's is having an asymptote. Okay, so the tangent inverse will be okay. I think this 3 will be enough for most of calculation in the inverse trigonometric functions. Maybe let me give you some questions related to this inverse. Okay, uh, simplify cos tangent inverse x. Okay. Okay. To simplify this, we can start with uh, let y is equal tangent x. Okay. All right. Oh, sorry. Tangent inverse. Sorry. So x is tangent y, and in most of inverse trigonometry, when you want to simplify, I prefer to draw in a triangle so that you can easily getting the visuals. So let's say this is the angle y, right? So let's say y, and then this will be x and 1, right? Because tangent y is x. X, so tangent, so x is, or tangent y is x from the triangle. So we can have this side as 1 plus x squared. All right. All right. And we know that from the question is asking about cosine. So cosine y. From the picture we see is 1 over square root of 1 plus x squared. Right? Got got it? Okay. Okay. Yeah, you can keep repeating and find another, maybe if you have sine and then tangent inverse x, and maybe tangent, or maybe a cosine, and you can have more and more variation. You can try and then look for the simplified version in terms of x, and I think that will be important later in I think in chapter 3. And I think until the second semester you will, it will be really really useful. Okay, that is I think the first additional lectures regarding the inverse functions. Okay, regarding the logarithmic and also the inverse trigonometric. Okay, so okay, I will stop the recording and you can repeat the video if you want.